So let's talk about a pretty radical idea today. What if we could build an AI that is by its very design incapable of lying about what it knows and what it's learned? We're going to dive into a concept called AnchorChain, which aims to do exactly that.
But before we get into the nuts and bolts, let's just start with the fundamental question. Think about it. Can we really trust an artificial intelligence if it can't even prove what it knew in the past?
And this quote just hits the nail on the head, doesn't it? With pretty much any AI you interact with today, whether it's a massive language model or a specialized vector database, there is literally no way to prove what it knew yesterday, or last week, or even 5 minutes ago.
This brings us to what's being called the AI's memory problem, or, to get a little more technical, the challenge of epistemic entropy.
So what does that actually mean? Well, an AI's memory isn't like a hard drive. It's not a stable, fixed record. It is constantly mutating as it learns new things. Its internal data points, what they call embeddings, are always shifting, and its history, it's basically being overwritten with every single update. So when an AI gives you an answer, it's not really remembering in the way we do. It's just reconstructing what it thinks it knew. The bottom line is, there's no proof of its past states, which is a huge reason we get problems like AI hallucinations.
And that, right there, is the heart of epistemic entropy. An AI's knowledge just naturally degrades and becomes impossible to verify over time. The analogy here is perfect. It's like trying to read a history book whose pages magically rewrite themselves every single day. Seriously, how could you ever trust a book like that?
Okay, so that's the problem, and it's a big one. So what's the fix? Well, this is where a system called AnchorChain comes into the picture. It's designed from the ground up to create a memory that is, fundamentally, honest.
The core idea behind AnchorChain is actually pretty straightforward, but it's also incredibly powerful. It takes every single state of an AI's memory and anchors it to an immutable, unchangeable public ledger. This creates a permanent, totally verifiable record of what that AI knew at any given moment in time.
So how does this thing actually work? How do you take a fleeting digital memory inside an AI and turn it into something permanent, something you can prove on a blockchain? Let's break it down.
It's a really clever four-step process. First, the AI's memory gets updated with new info. Simple enough. Second, that update is given a unique digital fingerprint, a cryptographic hash. Third, all of these individual fingerprints or hashes are bundled together in a super efficient way using something called a Merkle tree. Just think of it like a family tree for data, where every little piece of information rolls up until it connects to one single common ancestor at the top. And then finally, a single proof from the very top of that tree is committed to the Bitcoin SV blockchain, where it's locked in forever.
And what's really cool about this is that it's not some centralized system. It's distributed. That means every single AI agent out there can anchor its own memory all by itself. It keeps its autonomy while still contributing to this global standard of truth.
All right, this is where things get kind of mind-blowing. Let's talk about the sheer scale of this system, because this isn't just a cool concept, it actually has to work in the real world. This is what you could call the practical bandwidth of truth.
So the underlying network this is all built on, the BSV network, can already handle around 4 million transactions every second. That is a lot, but that's just our starting point. But here's the magic. Remember that clever Merkle tree structure we talked about? Because of that, a single one of those transactions can bundle proofs for, get this, up to 4.29 billion individual memory records.
So, you do the math. You multiply those two numbers and you get something so big it's hard to even wrap your head around. We are talking about the potential to verify 1.7 times 10 to the 16th AI states every single second. The scale is just astronomical.
So with all these crazy numbers, why does this actually matter? Well, it matters because it provides something that's been desperately missing from the world of AI, a real functional layer of accountability.
Just look at the difference here. On one hand, you've got the AI of today. It's a black box, right? Its history is a mystery. Its knowledge can change on a whim. With AnchorChain, you flip that on its head completely. You get an immutable memory, you get forensic traceability, and you get a provable internal state. You can literally pull up the receipts for everything the AI knows and has ever known.
So where does this become a total game changer?
Well, think about the really high-stakes fields. Scientific research, where you have to prove a model state for an experiment. The legal system, where you need an absolutely untamperable record of evidence. It's crucial for general machine accountability, for making AI research reproducible, and for being able to audit every single action an AI takes.
At the end of the day, this isn't just about data storage or another blockchain project.
This is framed as something much, much bigger. It's reliability engineering for cognition. We're talking about building trust directly into the very fabric of artificial intelligence.
And this quote just sums up the whole vision perfectly. The argument is simple. An AI that lies about its own past, or even one that just can't prove its past, is basically finished for any critical application. But an AI that can prove its memory, well, that becomes essential infrastructure for our future.
So really, what this technology does is build that missing bridge. It's a bridge between what an AI is computing internally and what we can prove externally. It connects its actions directly to verifiable, undeniable proof.
So, I'll leave you with this to chew on. If an AI's memory becomes cryptographically provable, if you know for a fact that it cannot be altered, what else becomes possible? What new worlds of science, law, and society open up when we can finally, truly trust what an AI remembers? That's definitely something to think about.